So, hope you can hear us. I'm not sure. Should we start the session?
One second. Just checking if audio is okay. No audio.
No audio?
No. 1, 2, 3.
1, 2, 3.
But audio is there?
You have audio? Because chat says
okay.
no? Okay. Perfect. Yeah, then let's start, I would say. So, hello everybody. Welcome to our session on demystifying video analytics on the edge. I'm Stefanie Grois. I'm an IoT solution architect at Microsoft. And I have my beautiful colleague here.
I am Jota. People call me Jota. I'm called Joao. I lead the AI Ranger team for EMEA and Asia. So I have a team of people specialized in AI and machine learning that help customers from London to Melbourne, all across all the time zones. So I'll go on then. So in terms of what we wanted to talk about today is about why are we seeing more and more uses of AI on the edge, and why is it important, particularly for video scenarios? Okay, so as a bit of motivation, so we all know that video is everywhere these days, right? Cameras are everywhere, in shops, in cars, in supermarkets, in petrol stations, everywhere, right? And someone or something has to process these sources of video, right? So what you're seeing is that there is a very, very, very strong use case both for automation and for fast response time. So I put these two images here to demonstrate. The left one is on a surveillance center, and I actually had a use case last year where a customer had 8,000 cameras in a surveillance center in Argentina, where they received video feeds from all over the world, including from India, so across continents. And basically they had people staring to screens and looking for weird things happening in factories or security, safety, multiple scenarios, right? And it's those situations where the camera feed changes every 15 seconds. So it's a bit, you just have to monitor a lot of video feeds. It's a difficult job, right? And the customer basically said, I'm running out of physical space for monitors, and I'm running out of the ability to hire more people just to look at screens, right? So it is a perfect use case for this type of capability. The example on the right is more for the case of fast response times, where if there's an accident or if there's a fire or something, we may not want to wait for someone to actually be looking what's happening to trigger an alarm, right? We want something automated to at least flag something is fishy here, and then action can happen, okay? One other use case that I have for this, a real use case actually, is in one of our customers there. The scenario is for workplace safety. Okay, so in a factory scenario where they have both the danger of dangerous chemicals leaking into the factory floor, or more common in warehouses where there's people with forklifts, and there are accidents. And one of the requests we had was actually because of an accident where a forklift hit an employee. So they want to put in places to have some safeguards in their in this case, warehouse floor. There's also a very strong case for new applications. So this is a German scenario with 0G, which is part of Lufthansa Group. And their business case is all about when an airplane is parking in an airport, there's a certain protocol into what's happening on the floor, right? In terms of the refueling, the luggage, the passengers, the cleaning crew, etc., right? And what they did using the technology that we're going to demonstrate is a system to orchestrate and try to optimize this protocol, okay, of loading and unloading aircraft, okay? And just as a small funny story, right? So we're talking about video analytics on the edge. And if you look at the image carefully, on the bottom, you actually see a sort of a GPU. So this is obviously a misclassification, and it's not exactly what we are planning.
It's called ground power unit.
Yeah. No, the identification is correct. We just thought, that's not a GPU, That's not what we have in mind. But there's plenty of use cases, okay? The scenarios that I'm seeing more is for either security, so physical security of locations, or workplace safety or security, like people wearing helmets or the forklift example, etc. I actually had an interesting use case, another one, just 2 weeks ago, where a company operates mines, and the mines have little connectivity, and they want to see if people using the forklifts and trucks, etc., are tired. If they are, smoking, or if they are heating, or if they are, dozing off or something. So they actually have cameras looking at the drivers to detect, and they want to try to detect any situation that can lead to a security problem, not a safety problem. Okay, so there's many new applications, and all this is based or leveraged by the. I hesitate about the word to use, but the fact that neural networks have increasing capabilities to really good levels of quality, especially if trained in specific domains of technology, right, of usage. This is obviously a bit of just a bad example, but you have image classification. So what's on this image? It's a cat, what's in this image, and more than one possibility is allowed. What are the objects that are in this image, or even isolating and segmenting each of those objects. So this technology wasn't in place 10 years ago or 5 years ago even maybe, and now it's commonplace, right? So, Shivi, I think you have...
Yeah, exactly. So what was not commonplace 10 years ago was the bandwidth and the connectivity into the... No, that's not right, Jota.
What's Azure? I don't have an Azure.
You touched it, Never touch a running system. So what was not there 5 or 10 years ago was also the bandwidth. Meaning if you remember early on, right, when you were younger and you tried to connect to the internet, it made funny sounds and you heard your mother talking over the phone with ESDN. So that's not there anymore. And we really came a long way, meaning in general, in Germany, we didn't, but in all the rest of the countries we did. And also in terms of connectivity of individual devices, meaning with the SIM cards and mobile networks, we can really connect from very remote places, right? And especially the bandwidth part is very, very important for video analytics, as you can imagine, because at some point, even if it's on the edge, you want to upload at least something into the cloud, be it the inferencing part, or be it maybe batched videos, or even the live recording. So in terms of hardware, what that means, also the rise of computing power, is that we have more performance into smaller and smaller form factors, meaning it's resulting low-cost hardware, so to say. Imagine it wasn't possible 20 years ago, 10 years ago, to buy a device that is here. I'm not sure if the people on the virtually can see it, but this is a Jetson Nano. It's actually also the one in the middle. And it has a price point about 100 euros and an integrated GPU that can run 0.5 teraflops. We also have some local servers like the Intel NUC on the upper right picture, or also the Azure Percept. I think there will be a session following this one, or the next one on Azure Percept as well. The other picture on the down left is a Raspberry Pi that everybody knows, and it was presented multiple times. It's also inside the Cloudray, right? Derivative of it, Revolution Pi, and the famous Vision AI kit on the right. Maybe some of you also know that. That was very famous like 3 years ago with the first service running on the edge with video analytics. So, but what does actually Azure have in this space? So what do we have? How can we actually enable video analytics on the edge? So of course, we have our own appliances, which means the Azure Stack series. There are some derivatives of it, meaning Azure Stack Edge, Azure Stack HCI, and Azure Stack Hub, where we can run the containers for live video analytics on the edge. Please no comments about it, because some have very strong opinions about the stacks. The second one is the Percept kit that I've already mentioned. This is also possible. But in terms of services, what we have is the custom vision.ai. It's a PaaS service where you can collect images, train these images, label these images, and then also have maybe as an output the container and put it onto the edge hardware. Then also what we have is Azure AutoML for images and data labeler. You mentioned it's in preview, right, Joao?
Yeah, it's a preview service, but you can use it today and basically applies the same idea of AutoML. So it looks for an ideal neural network to use and a set of configurations to use. And it's actually really, really cool. So it's something that I strongly recommend people try. And we also have the data labeler where what it allows you to do is here's an image and you can say here's a cat, here's a dog, here's a truck, etc. Right? And the way customers are using this together is, here's a detection in a camera saying there's a fire in my apartment and there's no fire, right? So that image can be fed back into the system so that someone says lack of fire or something, right? And then the model retrained using that new image, right? So new false positive case of scenario. Anyway, this is really cool technology. I would highly recommend people try it out.
So I didn't know personally that it existed, so glad that you mentioned it, Joao. This doesn't work at all. Okay, cool. So the other thing that we actually are also presenting today, and this is really cool, is spatial analysis. Meaning that in this picture, you can see some people moving through a retail store, and AI can actually detect the paths that they are moving and following them. So as you can see on the picture, it doesn't mix the bounding boxes of the people, because it knows what bounding box belongs to what person following the paths. This is spatial analysis, so 3D AI detection of people inside a room, basically. And that's very interesting, and we're also demoing it today. And the last part, where actually almost everything we are showing today, or everything we are showing today is based on, is the service called Azure Video Analyzer on the bottom right. And we have also heard from some of you guys presenting earlier that it's of course connected to Azure IoT Hub and it's part of Iot Edge story. But yeah, it's a special service for video analytics on the edge, but also in the cloud. So as we have already heard some of you folks presenting today, I will keep this short, okay? So everybody, or most of you probably know the IoT Hub, what it's for. The main part we have here, it's the cloud gateway for IoT devices that Azure offers, the PaaS service, and basically enabling device management, bidirectional communication via commands, properties, and stuff. And also built in the security and basically also the provisioning with an extra service called device provisioning service, and the edge capabilities that we have. So to enable offline and disconnected scenarios on the shop floor. If we come to Iot Edge, I just want to emphasize what was already said, because I'm not sure who is joining virtually, if you also joined the sessions previously today. So Iot Edge is nothing else than a container runtime based on the Mobi engine, but as you can also use the Docker CE version or Docker Enterprise even. Docker CE, it's important because it will only run on the Jetson Nano. There's no possibility to install the Mobi engine. I've read it's on the roadmap, so if anybody else knows if it's available, it would be cool. But I've just installed it this weekend, and it's only running with Docker CE version. Community edition. So, but basically the Iot Edge it's just a runtime based on Docker, right? And can sit on any Linux. We are supporting Ubuntu 18.04 and 20.04 is in the pipeline, as well as the Red Hat. And also the Raspbian Stretch or Raspbian OS. It's first tier, and the second tier that we are not supporting but is also running because it's just a runtime is, for example, Yocto and CentOS and everything around that. So, and what does it enable us? So it's enabling us to run containers on the edge, that has been mentioned previously. It also has a security daemon on top of it, where you can securely connect to the cloud via TPM, certificates or key pair. And there is also some cool new services coming in this regard. For example, you can use the identity service to also run an agent that is not connected to Iot Edge with Iot Hub as a host application. That was released with Azure Iot Edge 1.2, so that you are not solely dependent on the Azure Iot Edge daemon or service to run host applications. but being connected to Iot Hub. The only other thing that we offered was the SDK, but this is a little bit different, and is especially for Azure Device Update interesting, and also for agent-based code and applications. So how does it work? How do we actually deploy something to the edge? Here you can see we have the Iot Hub in the middle because it's the cloud gateway. On the left side, we have the edge device. In this case, it's an edge device that is connected to RTSP cameras or alternative cameras, but we are using RTSP. And on the right side, you see, in this case, we have RTSP Sim, RTSP Simulator, the Azure Video Analyzer for Edge, and some vision model that we are running. And so these containers are sitting in a container registry. It could be that it's the Microsoft container registry, another container registry like Docker Hub, or my own one for the custom modules. And these are sitting there, right? And what happens here is that Azure Iot Hub generates a workload description or a manifest in JSON, and it was presented before. I think you presented it, right? Where you can actually see what will be deployed to the edge, saying what containers, what ports, what container create options, and environment variables and stuff. And this gets basically pushed to the edge. The edge agent and the edge hub will detect if there is a delta in terms of pulling containers and configurations, and it will be pushed onto the device. So this is the flow, how it actually works. But we will show parts of it, but not in detail, because we knew that there was another session on Edge before us. So we will not show every detail, but the ones that are relevant for real-time analytics on the edge. So if we go a little bit deeper, the Jetson, we are talking today about the Jetson, right? And the Jetson is part of a series of integrated GPUs that NVIDIA is offering. On the left, so the sizes in terms of computing power go from left to right, and we are using the Jetson Nano. And then, as I already said, there is a price point of around €100, but you have to be aware that for €100 you only buy basically the motherboard or the platine. You need the box around it, you need some antennas. You also need some cable to plug into your network, because it's not delivered. I didn't know. I had to buy everything separately. That also applies for the other ones. I think there are some offerings with some specialized shops in internet where you can buy everything as a bundle, but be aware that for this price point of €100, you only get the platine, the bare metal one. Right. And there is also the Jetson TX2, the Xavier, and the bigger Xavier. And as far as I know, but please correct me if it has changed, because the prices in graphic cards jumped, right, because of the chip shortage. This one should be around 400, and this one was, when I looked last, around 1,200 or something like that. But it's still very affordable, right, if you look some years ago. And the other thing I want to mention is a little bit more geeky. So these boards are manufactured in around 7 or 10 nanometers, and for the new dedicated GPUs that NVIDIA will release in 2022, which will be the RTX 4000 series, they will switch to 5 nanometers, which is really crazy if you think about how big what actually one transistor will be then. And for the dedicated GPUs, they are currently, as far as I know, running on 7 nanometers. And the main customer for 5 nanometer transistors is actually Apple. So they are the ones who are buying all the smaller chips. And if you just look at the comparison, so NVIDIA has 7 nanometers, and Intel, up to last year, they are switching now, but they still use the 14 nanometers, basically losing the pole position to AMD, which switched to 7 nanometers a few years ago. And this has major impact, because you get many more transistors on one board, and being more cost effective, but increasing performance. So this is actually what the GPU manufacturers and also CPU manufacturers want to achieve. And this is also where the smaller form factors with increasing power comes from. Okay, but enough talk. Pray to the demo gods that everything will go well. We are now showing some demos, but I pre-recorded everything, so if nothing is working, we can still switch. So, okay. What I want to show you first is the NVIDIA Jetson Nano as an edge device. And this is not at all surprising. So,
can you maybe increase the text size?
Yeah, thank you. Yeah, I was forgetting it. So this is the IoT Hub, right? It's a PaaS service and it's the cloud gateway. And this is actually the one that I always use. So don't be afraid. There are multiple devices. I have about 100 IoT devices because I ran a script and it popped up the devices and did some load tests in there. But anyway, so we have some edge devices here, and this is my Jetson Nano that is actually sitting in front of me, and I hope it's still running. And there you can see the containers that are actually pushed onto the device, what I've showed earlier, right? There are the system modules, which is Edge Agent and Edge Hub. But the ones that are specific to video analytics on the edge is really the Azure Video Analyzer service as an edge module. The other two ones are specific to the use case I'm going to show, which means the RTSP simulator is just a simulator for the RTSP cam, but you can also use your own RTSP camera, then you do not need the simulator. It only sets up a RTSP server to connect to via the RTSP protocol. And the AVA extension here, that's important because this one is actually building the bridge between the Azure Video Analyzer service that Microsoft offers to the DeepStream SDK that is running on the Jetson that is specific to NVIDIA. And we need this container to actually run the DeepStream and run the gRPC server that integrates with Azure Video Analyzer. Okay. So much to that. So let's pray to the demo gods again. So if you can see, this is really the Jetson Nano that is in front of me. And what I want to show is what do we have here in particular. I can also type it. So the IoT Edge version that is on it is the 1.2.5. That's the most recent one. That's not surprising. Then we also have Docker version. It won't work because I didn't put a sudo in there. But this is the Docker version that is running. It's an older version. The reason is that this is the image from NVIDIA that is running on the device. And for compatibility reasons, I had to install the DeepStream version 5.1. The most recent one is 6.0, and the 5.1 is approximately 1 year old. So the thing with the Jetson Nano that I found out later on is do not change anything. You always have to reflash completely. Because the Jetson Nano is offering something called the chat pack. And the chat pack is running on the device, and it gives you all the libraries and all the packages that you need for analytics on the edge with the Jetson. What that means is there is, except the DeepStream that's sits on top of it, but the whole drivers that are very specific, the CUDA drivers, the Tensor RT version, and everything else, also the Docker version, is specific to this package. You can upgrade it, but then the driver versions will change and will create incompatibilities, and that happened to me for the past 2 weeks, giving me a lot of headaches. So you have to be really careful with the version that you're putting onto the Jetson. And also the container that is running on it must be the same DeepStream. The DeepStream version that is running on the container must be the same as the Jetpack that is installed on the Jetson. No exceptions. So even if you have Jetson version 4.4 and you would have, let's just say, 4.4.1 version of the container, it would not run. It does not have any compatibility to older versions. It's creating a lot of headaches. So, but anyway, apart from that, what else do we have? I always have to use this command because I cannot. So I cannot memorize what's on it. So the top command basically gives you the different information about the CPU and memory. As you can see, I have a problem, and I'm sure this will be the reason why the demo will not run properly, but because we have like 63 to 70% CPU usage, and we will run a ResNet 18 later on, so it could create a little bit of stress on the device. What else do we have? So it's based on Tegra, right? It's based on Tegra X1. So you can also watch how actually, okay, I need to look it up. How actually, sorry for that, and I can't find it. Yeah, I'm using it a lot. Where is it? Yeah, there it is. Of course, the most recent one. So you can also run something like that. And why I'm showing you that is it will help you a lot. No, that's not correct. It will help you a lot in actually identifying the right versions that are on the device, because you really need to know that. You see, there is revision 5.1, and that gives you a clue that you have this version and you need the DeepStream compatible to that one. Then also here, this command so will show you the Jetpack version. You can see the Jetpack version 4.5 is installed on ARM64. That's also an important part, right? So Jetson Nano, the whole series is ARM64. And the tutorials that we found in the internet, and that's very important, are mostly built for VMs and Tesla T4s on AMD 64. And of course, this is not compatible with each other, right? Because it's a different kernel. So what we had to do also here, so if anybody shows up the demo that we will show, it won't work because it's only for AMD 64. We had to build the Docker file again for ARM64 v8. Okay, but that's basically the device side. Let's look more into the VS Code side as well. I already increased the font size. I hope it's enough. But what I wanted to show you also is the deployment manifest for a little bit, specific to the live video analytics, right? We have already seen the containers in Iot Hub, but we can also see them here again with VS Code and deploy via VS Code directly. Meaning what is interesting is this module here, Azure Video Analyzer Edge. It will just get pulled from the standard mcr.microsoft.com. So it's an official image. You don't have to do anything really. You don't have to build it from scratch. That's actually cool. The only thing you need to give the module as an environment variable is the output folder and the app data folder. I use the standard ones. And for the AVA extension, so that's the custom Docker file, what you need to do is to give a little bit more input on where it can find the inference config and what it's actually going to inference and stuff. You can find it here, car, color, and car type. This is what we are going to see. And here you can see it's also hosted on my personal container registry. It's not hosted on mcr.microsoft.com. For the AVA service itself, but this is also part of the tutorial, it's well explained, you need to make some additions to the desired properties, meaning that you have to provision a provisioning token for the service so that the Edge can actually communicate with the service via HTTPS. That's what it needs, because it will upload the videos into the service and then show it. But that's the Edge side for the whole thing, for NVIDIA, right? I would say we would move to the video analyzer side, because now it was quite generic, wasn't it?
Yeah.
Do you want to switch?
But you have another demo, right?
Yeah, I have
another.
Maybe. We can also stay with mine, no problem.
So I was just told that we don't have the camera feed is not working, so people are not seeing us.
What?
At home.
What? I was giving my best.
So the second part, the IoT Hub and IoT Edge part are the foundations, right? Are the minimum things that have to be in place for then solutions to be built on top, right? Azure Video Analyzer for Edge is one of those solutions that you build on top. Okay, so Azure Video Analyzer is a newly branded service, okay, but it's actually not a new service. So it has two parts, the Azure Visualizer for Media and Azure Visualizer for Edge. The top part is an example of Azure Visualizer for Media, which until about 2 months ago was known as Video Indexer, Azure Video Indexer. Okay, so the idea was to extract insights from video, like detect famous people, or do speech transcription, or name entity recognition, other capabilities on top of live video. Okay, that's the old Video Indexer, now known as Azure Visualizer for Media. The bottom part is an example of Azure Visualizer for Edge, which was previously known as Azure Video Analytics. Okay. Which has been in preview for a few months already. Okay, and it allows, in this example, what we're seeing is cognitive services, the spatial analysis part. But basically, what we did was we joined up all together in a coherent story from the edge to the cloud. Okay, so not a new service, just a rename of an existing service. In terms of main capabilities, so. The slide says comprehensive video analytics pipeline, and the idea is that you can define video processing pipelines.
There is the problem with the technology here?
Yeah, just the video, the camera stream is not...
It's not what?
It's not being streamed. Maybe you missed the button there.
Okay.
Sorry, folks, just having technical assistance here to fix the video feed.
Oh, man.
How do you assume that the camera is not?
Because my partner just told me.
Okay.
That's insider knowledge,
Insider knowledge, yeah. Okay, so, hey folks, it's me again.
You can go over.
Okay.
Do you have both microphones?
So we had a technical assistance here. Thanks, Rolf. So we have a pipeline where, so this kind of video processing systems usually work with pipelines. You set up pipelines with different processing steps. For example, you capture the video, which was what the RTSP stream SIM module was doing. Another frequent step is, for example, you can downscale the video or lower the frame rate. That would be a second step, right? And then maybe you do movement detection, and maybe you do upload to cloud. So you set up pipelines like this, okay? And what AVA allows you to do is define these pipelines in a way that they have the same structure across the edge and the cloud in Azure. Okay. So this is the first highlight. Another one is obviously there has to be a capability of capturing video and uploading it to Azure, right? That comes without saying. But one of the interesting things that AVA also includes is the ability to plug into the device. So imagine you have a camera that is monitoring some sort of situation, and suddenly generates, here's movement. There's a movement at night, and nothing should be happening, okay? And because there's low bandwidth, the video is not being uploaded, okay, continuously, right? That alert is sent to Azure, then someone receives maybe a text message in the phone and wants to connect, and AVA gives you the ability to go over the open port into the device and stream up the open socket, technically, right? And stream up the video that's coming from the camera. Okay, so it's like the connection is open from the device to Azure, and you can use that same connection because it's bidirectional to see what video is being streamed up. Okay, and it has a latency in the order of low seconds. Okay, it has some latency, but it's low seconds. So another one is, hardware optimized AI on the edge. This actually depends. This was the struggles. These were the struggles that Steffi was describing. It's actually in large part depends on the hardware itself. So a large part of us preparing this session was getting DeepStream to work. Nothing related to Azure. It's all about DeepStream and their drivers, right? It's that has to be done. That depends on the specific hardware, the drivers, the capabilities that are there, right? The Docker runtimes, etc. But we give you the ability to work both with Intel Opal Vino, so Intel's platform for video processing, and NVIDIA DeepStream. And you can also use the spatial analytics containers on the edge with minimum effort, which is what I'm going to demonstrate. Another one is, so Azure Visualizer, although we ship with spatial analysis, it's out of the box, you can just deploy and use, right? It's actually a bring your own model kind of thing, right? If you have your own custom vision model for your own domain, you can just bring it to the device, okay? It is your responsibility to make sure that it runs on the hardware that you have, right? And if you try to process 4 video streams with a ResNet 60 or 50, right? It has to run, right? That doesn't depend on us, right? But you can pick models from multiple sources. As long as it runs on the hardware and it can be containerized, we should be able to integrate with it. And this one I already mentioned. It's more about the enterprise landscape for AVA in terms of enterprise management. And the last one, this is more of a feature that I'll demonstrate, is that when you are playing the video, we have a rich player that shows you not only the video, but things like bounding boxes. So we don't actually edit the video to draw the bounding boxes, but we have a player that will overlap the video with bounding boxes, for example, or movement trails, things like that. And that player can be either viewed in Azure or embedded in our applications, or even embedded in Power BI, if you wanted to do that. So in terms of the overall picture of Azure Visualizer, I think I mentioned most of this, right? The Edge component on the left with the pipeline, video capture, some processing and publish video. It goes to the cloud, and then in the media part, there can also be pipelines to do further processing, okay? Like streaming in different formats for different devices and things like that. So a breadth of, it spans from the edge until...
So does it mean that Azure Video Analysis is also analyzing stuff? Itself?
So Visualizer can be seen as a video transport mechanism, okay? And in that video transport mechanism, you can plug in different processing components, including doing video analysis, okay? But this is not as, the previous service was called Azure Video Analytics.
Live Video Analytics.
Live Video Analytics, sorry. The name is a bit of a misnomer because this is basically a video transport mechanism and pipeline, okay? It doesn't come built in with any pre-analytics processes unless you configure them, okay? So some key concepts just before I go into the demos. So one is the pipeline topology, and the other is pipeline or live pipeline. These are the key ideas. So you see, pipeline topology is like a class in object-oriented programming. Okay, so it's the template. Okay, and you say, in this example, you can see here, there's a video source, and then there's a processor and a sink, and then underneath there's a bunch of processors and another sink. This is the definition of the template, okay? And then you instantiate this template with pipelines. And what you do when you instantiate it is you fill in parameters. For example, the template may say, I have a URL for an RTSP feed. And then when you instantiate it, you give it a specific value, okay? This also means that if you have a Jetson Nano with 4 cameras, you can have one topology and 4 instances of the same topology, each processing its own video feed, okay? As an example. And then the other components are basically the sources, the processors, and the sinks. So the origin of the video, what you do it in the middle, and where you send it to. Okay, so and there's a list here. So key sources are RTSP1, key destinations are either upload the video or store the video locally, and on the right side, different things that you can plug in processing. I think this makes it a bit more real. This is just some scenarios that are possible with AVA. The first one, which I'll demonstrate, is just a simple upload the video to Azure. The second one is if there's movement, then upload a message saying there was movement. And you can also do the next one, which is if there's movement, say that there was movement and record. Okay, so from the moment you detect it, start recording. And the last one, which is similar to what Steffi is going to show, is if there's movement, call an AI service, for example, to see, maybe it's a cat in the video at night in a security camera, right? And just send that notification. So using an AI service. Steffi, over to you.
Yeah. So
again,
this is actually the demo I was struggling with for one whole week, actually. So what it does is actually quite simple. You have the source that Joao explained and the sink. But in between, you have this extension that is completely dependable on the NVIDIA hardware. And what the NVIDIA hardware's task basically is to supply us with this server component, the gRPC server. So the AVA service is only like delivering us the interface for it, but not the actual server. So this has to be done with the NVIDIA in the Docker file, where also the NVIDIA DeepStream is running. And what we have inside the container is nothing new. It's actually what Joao was just describing. So the pipeline, let's say, of the inferencing pipeline will run in the NVIDIA DeepStream SDK and not as part of AVA or something like that, because AVA is not capable of running analytics services. So let's switch to the demo. And now it can So let's start with the Azure Video Analytics side. So Joao just explained that we have this kind of pipeline. So pipeline is a little bit misleading here, right? Because we have an analytics pipeline where the inferencing is going on, but we also have a media graph pipeline for the Azure Video Analyzer that basically tell us, okay, this is the source, this is the stuff in between, and this is the sync that we want to use.
Sorry, Chef, just a quick note. Media graph is a concept from live video analytics. Now it's called pipeline topologies.
Yeah, exactly. Now it's called pipeline topology, so also a renaming. But yeah, that's actually how it is. So in terms of the topology, this does not work. This is the actual topology. So this is the media graph or live pipeline topology or whatever. So you can see here it's called inferencing with gRPC extension. And then you have the RTSP and all the parameters that you are supplying for RTSP. Here, this is very important. You have here is the interface, right? So the AVA extension is a second module or is a special custom Docker file or Edge module that will receive the information of the video on port 5001. And it will also supply us with a very simple web interface that I will also show on port 80. And so here we have the sources we have just seen the parameters, and now we're starting with the sources. That's nothing new. The RTSP source, sorry, it's like hanging a bit. The RTSP source is there. Then we have the processors. These are the ones in the middle, where we have the gRPC extension and some variables here, and these variables go into another file. Then we have some info about the height and the width of the frame that we want to see, and also about the samples and stuff. But the also important part is the sync. So here we only have an Iot Hub message sync. And what that means is we will only send the inferencing data into the cloud. We will not send any video data into the cloud. That's what Joao will show later on. But for this, I think that would have flattened my Jetson Nano completely if I also uploaded video, because it's really running very tight. So we are only sending the telemetry data. So that's one thing. The other thing is that you have this operations.json. And as you can see, this is very manual process. I think we have a better solution here also to create a pipeline topology in this operations.json much easier, which also Joao will show later, but we wanted to show you how the fundamentals is actually built together. So the operations JSON is just where you actually supply the values for that. The live topology is only parameters and stuff. Think about ARM templates, right? Where you only have the parameters and let's say the different fields and stuff, but the values then actually run in the template, not in the parameters JSON. That could be something to identify with. Here you can see we have the RTSP simulator, and we actually fill in the values. So the username and the password is admin, which is great. And here, this is also very important. We have the different steps. So live pipeline activate, deactivate, delete. This is important because it will not, of course, run through everything. So you start it, and then only if you press enter, it will basically go to the next step. This is something that I always missed, and then I pressed enter and it didn't show anything. So, and to actually get it running, what you need to do, or what the service client in the back needs to do, is to send a direct method via Iot Hub. We have seen the concept early on as well. It sends a direct method with the URL and the instructions and everything of the pipeline topology onto the device. So this is what's going to happen. We have a .NET application here where I basically set the different parameters, what device it should be or what module ID I have here, where the operations JSON is located, and also the URL for the topology. So this is just the execution. And what I need to do now is to... And
Stefanie, can I just add one note?
Yeah, sure.
So we have, in terms of the demo that Stefanie is showing, there are two JSON things. One is the deployment manifest that tells you what containers have to run on the edge. Okay, that's the first step. That's the core capabilities of Iot Edge. After you have the AVA component running, it has a sort of a state machine / database. So you say, here's a topology, save it. And then it says, start a topology, so start a pipeline, right? And then stop a pipeline, and then delete a topology or update a topology. The operations that Steffi was showing was to control this state of the AVA edge, okay? But it's not to be confused with the first, which is the deployment manifest part, okay? And the sample application is basically a control application, just a sample to send commands to the device. You can actually also do it in the browser in the Iot Edge user interface or Iot Hub.
So, all right, let's try again. Because the fun part is it just crashed the Wi-Fi card on the Jetson right in this moment, so I didn't have any Wi-Fi anymore, which is really great. Yeah. Okay. But it is connected, so. Do I really have to show the pre-record stuff now? Really? Really? No.
Don't worry, folks, we have a backup plan.
Okay. I will show the pre-recorded video, because I don't know what the reason is. Both is connected, so it only takes time. Okay. This is actually what will go on. I hope I can do full screen.
Yeah.
Can you see? All right. So on the left, you can probably not read it, but I just put in .NET Run, and it will start the whole graph, right? As I just showed with the different steps in the operations.json where the info is. And then actually what I observed is that now the gRPC server that we've seen would start up, but for me, it takes a really long time for the Jetson Nano to do so. It will do eventually, but on the right side, on the bottom, you can see what happens on the Jetson Nano. And I cheated a bit because it takes about 1 to 2 minutes until it spins up. And then you can see it works. So it's doing the inferencing on the right bottom. The video on the top where it detects the cars as an object and also the color of the cars. And on the left side, you can see, okay, that's the real inferencing that's happening and is being sent into Iot Hub. So this is actually what's running. On the right side, you see also that it is using the threads of the actual CUDA drivers that are on it, that are on the Jetson. What I also observed, because I'm very transparent, because this seems to be something with the hardware, is it's running full. So the RAM and everything is really completely tight. So I have 4 gigabyte of RAM, and it runs on these 4 gigabyte with 100% CPU and GPU, because it's a shared CPU and GPU RAM, shared between this, because it's an integrated GPU. And it will always do some inferencing, and then it will stop. And it will spin up again after a minute, and it will stop. And it will spin up after a minute, and it will stop. I've heard some stuff what it could be. It could be the SD card, but I have the most expensive ones, so the SD card Extreme. So I don't think it is a read or write issue. And the other thing I observed is that sometimes I've read that the Jetson Nano has a memory leak. Why am I saying this? Because the title of the session today is Practical Advice. And this is also part of Practical Advice, that we hope to help someone who is listening to us not to run into the same issues with compatibility and with also running stuff on the device. To be fair, what we did here is actually built for a Tesla T4. It was not built for the Jetson Nano. So the ResNet model, it shouldn't make any implication, but I'm just saying. So the ResNet 18 model that we are running was actually for another demo. And what we did is that we adapted the container from AMD 64 for the Tesla T4 to, I don't know why it's not running. I'm frustrated again. It was actually built for AMD. And what is also no, that's not the right thing. What's also very important, if you somehow want to do it yourself, is you have to really pick the right base image. And for the Jetson and the integrated GPUs, it always means L4T, Linux for Tegra. So if you use the normal deep stream, it always means like, hey, I'm a dedicated GPU, I need the NVIDIA toolkit. You also do not need the NVIDIA toolkit. That also happened to me. It's all in the Jetpack. The Jetpack is a fully functional, complete video analytics framework, so to say. And the L4T images are the ones for the Jetson. And this is actually what we built in the Docker container, where it runs basically the server in the end and starts up via the shell with the server and the inferencing pipeline running on it. So, yeah. So the demo gods were not completely happy with me. I don't know why the networking doesn't work, but it would have been the same outcome, I hope.
Yeah.
That was the demo, I think.
Okay, so maybe we can change my laptop for the second part. Can I swap it around? Sorry.
No problem.
So I hope you can see my screen.
Can someone maybe check the stream? That would be cool, if everything works.
Okay, so the other demo that I'll be showing you some real demos with Azure Visualizer. In one or two of the things that I'm going to show you the computer vision for spatial analysis component. Okay, this is an Azure cognitive service, so it's pre-made AI with some customization, but essentially pre-made AI, and you can use it either in Azure via APIs and the portal, or you can configure it and export a container that you can run on the edge. Okay, so the same capabilities are available to run on devices like, not the Jetson Nano in particular, but the Intel NUC, for example. But I'll go to that. In terms of the functionality, the capabilities that are in this container, they're listed here on the left side. So we can detect people, track people, detect skeletons, detect face masks, which is very contemporary, I would say, and have a detection of regions of interest. Okay, so for example, I just want to count people in this region. Okay, so these are built-in capabilities. Like I said, this is deployable as a container on the edge. It does require an NVIDIA Tesla GPU. We were still discussing exactly about the T4 part because I'll be doing a demo with a K80, which is not a T4. So we need some clarity here. And at the moment, it's only AMD 64. Okay, so instead of using the Jetson device, I provisioned a VM in Azure, an NC6 with one GPU, one K80, and that's what I'm using for the demos. In the screenshots in the middle, you see some examples of what the container allows you to do. On the image on the top, we have different people, and there's a little purple triangle saying what's the distance between them. Okay, a calculation. We can also do counting people in a queues. This may not be relevant for this use case, but when you have supermarkets, one of the key things they have is about scheduling. How many people are in the tellers at every single moment, right? So for some use cases, it's more important. And then on the right side, you have the overall architecture, okay? One note there at the bottom is about responsible use deployment for computer vision spatial analysis. So when you deploy the service, you have to check a tick a check mark, confirming that your use case has done due diligence in terms of respecting things like people privacy, sensitive use cases, harm to human life, etc. Okay, it's your responsibility, right? This is a bit of an overview on this. Let me then go to demos. The first, just as a bit of setup, I hope you can see.
But it's also reset, Joao. I don't know.
Sorry?
It's also reset the connection, like with mine. Hey.
Okay. Yeah. So.
Everybody needs to look away now.
Yeah. I don't know what happened here. Okay. So I'm connected to a VM in Azure with a GPU. Okay. Just to show you what this is. Okay. It's a Tesla K80. Okay. GPU there. To show you what's running there. So just to confirm that we have it, right? So we have the Azure Visualizer Edge, and then the two other modules that Steffi already described. The RTSP scene, we have the container for spatial analysis, and you have YOLO v3, which it's a lighter model than the ResNet, I believe, but I'll not be using this one. I'll be using the other ones. That was for another demo. So this is all I wanted to show, just to prove to you that we have things running on the device. In terms of the rest, so Steffi showed you how to do things, oops, not this one, the hard way. Okay, so the lower level way, or you end up manipulating JSON files for the topologies, okay? So part of AVA is actually an extension for VS Code that gives you a better user interface to navigate what's on the device, okay?
And how would I install it?
It's a it's basically a Visual Studio Code extensions. You go to the extensions, look for Azure Visualizer, and it's deployed, okay? Anyone can do it. Okay, so what we're seeing here on the top is my IoT instance, my Azure IoT Hub instance, and then it's saying I only have one device in this one, my NC6 Edge VM in Northern Europe, and in here I have AVA Edge deployed, and inside AVA Edge, let me just collapse this, I have 5 topologies, okay, so 5 definitions of processes. One is called CVR to video sync, and this is basically continuous video recording to video. Okay, so let me show you this this template. So behind the scenes, all of this is JSON. Okay, and what happened right now when I did right click was that the VS Code editor reached out to the VM in Azure, said, "Give me the detail of that topology." The device responded, and then it presented it on a better UI. Okay, but behind the scenes, this is not a local database. It's querying the device, the VM, in this case. Okay, so this is a really simple pipeline, right? Just receive an RTSP source, and then there are some parameters here. You can note that the username and the password are as variables, so I will need to supply those when I create the live pipeline, right? And then I'm saying, where to send it to, and it's going to send to a video called sample CVR video sync. Okay. And then what I would normally do is I would do right-click, create live pipeline, would create an instance. Okay, I already have an instance here, and just to show you what it is, it's basically the same user interface, but it has...
One question, Jota. So would this be the operations JSON I was showing?
Sort of, yes. Similar to. The operations JSON controls the deployment of these things. Mm-hmm. Okay, good question. But if you have access to this, you don't really need to use the lower level stuff, right? You may need to use the other lower level stuff if you're doing things like deploying a topology to 1,000 devices. Then you want to do it at scale in an automated way, and you wouldn't do this, right? But for development and see what's happening, this is perfect. Okay, so for this case, the instance, so the live pipeline, has a specific test password and user, and a specific video that I recorded out my window, and what I'm going to do is activate. Okay, and what's doing now is sending a message to the device. I have to maybe refresh. Sometimes it fails and it still works. Activate again. Okay. Successfully activated.
Oh, you were lucky.
Try it again. So one note is, remember, Azure Video Analytics is in preview, okay, and so is the VS Code extension, okay. So anyway, so this has been activated. So let me now go to the browser. Increase size. Okay, so this is my resource group with the demo, including the virtual machine. And let me go to the Azure Visualizer instance. And there's an option here for videos. Let me close this. And you'll see that one of them is saying recording, okay, which is the sample CVR video, okay? And if I click on it, I'll be able to see what that video that I recorded is being streamed in a loop, okay? It's being continuously sent up to Azure. So it thinks it's live, right? But because it's a simulator. So this is outside my window. And it's you can see the spinning because it's uploading the video, right? It's trying to show the live video. So just to make it a little more convenient, I'll click on live to stop it. And I can see the historical video because it recorded everything. Okay, so basically, this is the simplest possible case. I'm just streaming what's happening in a certain camera, okay, and be able to see it here. So before I continue, on the top there's this widget setup part, and there will be some options showing up on the right. If you want to embed the player in your own application, you can. Okay, and here's why, here's how, and it's also documented in documentation. And one of the reasons you may want to is that you can actually turn on the display of things like bounding boxes or attributes that the AVA is receiving. Okay, in this case, I'm not capturing anything; it's just free flow of data, right? But in some of the demos, I'll be showing this. Okay.
So in my case, the bounding boxes were actually driven by the deep stream, right?
Correct.
It was not done by Azure Video Analyzer itself on the edge. It was really by the deep stream. That was some feature there. Yeah.
So let me go again to VS Code, and let me stop this instance, deactivate, and let me show you another one. This one is event video recording. Okay, so the idea is similar. RTSP source in the beginning, video sync at the bottom, and then we see there's something called motion detection. Sometimes this crashes, okay, but now it works. Okay, so there's the parameters part. You can, for example, say that you don't want to look at motion in a certain region, like for example a door, not the whole image, right? So, but again, you can use variables. And it's looking at movement in windows of 1 second. And what is happening is this. Whenever it detects motion, it sends a signal to start recording. Okay? And then it will record a certain time period. And at the same time, it will send a message to Iot Hub saying there was movement. So it will send both the video when there's movement and the metadata. Okay? And this is the same idea. So this is the topology and this is the instance. Let me activate it. And I actually want to show you the JSON. You can show live JSON here.
No, you cannot.
No, I just have to try twice. This is a pre-made container. It's not like fully featured. Okay, so essentially, in terms of relevant settings, the main ones are you can set up the sensitivity. Right, for example, in this case, it's low sensitivity, right? So it's more or less stable. And usually, if cameras are in outdoor places and there's, from dark to light to, evening to night again, this will be impactful, right? Everybody who works in video would know that. Let me go to Azure now. So this is running. This instance is running. Refresh the page here. So the other one is no longer recording, and this one is. Okay, so for this demo, let me just go to the pre-recorded version. So I just actually, stop. Okay. I actually just recorded my girlfriend leaving home, staying outside for 20 seconds, and then coming back in, okay? And to prove, which is a bit difficult, that only the movement is being recorded, what you have on the right side is the full duration of the video, okay? And what you have in the bottom is what was sent up to Azure Video Analyzer, okay? And there's a detail here, which is this. You can say, when there's movement, you can say, record at least a certain number of seconds, and the minimum is 10. That's why I asked her to stay outside the door for 20 seconds, okay? There's also a really interesting feature, which is you can say, start recording before the event. Okay, so you can say the event happened at minute 1, and you can say I want the 20 seconds prior also, okay, which is really interesting for security. Okay, so what happened before? So what I'll do now is I'll just move this slightly. Okay, she's almost out the door, and then I'll play a bit of a challenge with Windows here, not Microsoft Windows, with Windows. I'll play this one, and I'll play this one. And now we wait for 10 seconds. Okay. So nothing is happening. I don't think the video is even, it's moving. So she came in. Okay, so the system detected movement. Oh, wait. It's actually showing bounding boxes, even though you can't see them, where it's detecting movement. And the original video is still, going. So, and then she'll come across again. Okay, so then that's when she got in. So I just wanted to prove to you that we were just capturing when there was movement. Okay, so the full duration was 1 minute of video, and the other one was cropped down just when there was movement. Okay, so a bit of a little like a demo just to prove you this. Okay, let me go again to. She'll go on eternally coming into window. I'll never forget this video. Let me deactivate. So let me show you about the more interesting ones, which are the spatial analysis ones. So what I showed you until now does not depend on spatial analysis. It's core capabilities of Azure Visualizer, okay? I think it's the Brussels zone crossing, okay? So let me show you this one. So we may have a little crash here.
Bist du als nächstes dran?
Okay. We did.
Ja, wir haben so ungefähr 10 Minuten.
Okay, so similar idea to before. So a signal gate and a video sync and a Iot Hub sync, but this time we have a computer vision extension. Okay, and when I added this box here, I had to give it the keys to access the cognitive service. Okay, so because of billing reasons, this has to be partially online. We have to be able to say to Azure, we're using this container, we're using this container, we're using this container, right? Because this is not for free. So let me go again and let me start this. Activates. This time it activated the first time. AVA, refresh. So this one is recording now. So this was person zone crossing with my phone. And let me turn on the bounding box here. Okay, so again, this is the camera outside my window. And you start seeing people coming. Sometimes there's a little bit of a delay, but it's saying a person, a unique ID. Okay, so it knows it's the same person, all right? And then on bottom it says the speed in feet per second. That doesn't always work. Okay, I have another demo where it works, but not in this case. And also the player is drawing these lines, and then there's a bicycle going by really quickly, right? But and it doesn't detect cars. It's not trying to detect cars. It's only trying to detect people. Okay, so it's not failing at detecting cars. It's just not trying to detect cars. Okay, so this is one example. The second one. So I'm not going to start the template. The template it's the same thing, but because I already have it pre-recorded here. So I'll show you the real case with a retail shop scenario. Okay, so we have a trial retail shop, I believe, with an employee. It's not showing anything. Now it started detecting that a person there. A second person comes in. The speed is still feet per second. I'm having a discussion with product group that it should be SI and should be meters per second. But there will be a third person coming in. Okay, still no feet per second, but then somehow it manages to adjust. And this is artifacts just of the uploading video, of the source video. Okay, so this is not AVA related. And then when the fourth person comes in, for some reason, okay, it stopped tracking just because it's no longer a thing of interest. Okay, but it's still monitoring who is where. Okay, where's the other person? Okay, so and now suddenly it actually is detecting the speed for everybody. Okay, so there may be a calibration here that I'm not aware of. I didn't have time to look into that, okay? So when basically this is what it's doing, it's overlaying the video that's being uploaded and the telemetry that Steffi showed that's also being uploaded, okay, about where people are and etc. Okay? And notice that this is not just people detection. It knows who the individual people are, okay? It has a unique ID on each person coming in, okay? So it's doing not only object detection, but object tracking. Okay, so this is actually pretty cool technology. Even though it seems like, hacky in terms of demo, this is really, really powerful for many scenarios. And so I think for demos, this was what I wanted to show. Just in terms of a closing wrap-up. Okay, so I'll go with the first. So in terms of solution design, and this is all real experiences. So one of the things to keep in mind is, what is the business case for a solution like this, considering cost? Okay, so for example, I mentioned to you the use case in a mine where they wanted to detect if people were fatigued or smoking or eating on the forklifts, etc., or the machines, whatever, right? So the way this works is they actually have people sitting and looking at the videos. Okay. Worse, they're looking at the videos offline. So the forklifts record the video. At the end of the day, someone goes in, extracts the disk, and then people stay 3 or 4 hours on fast forward looking at videos. Okay. Mining is not exactly a very high return business. Okay. So the conclusion for this use case is it's super interesting. We can do it, but it doesn't pay off for the business. Okay, it's simply the investment to wire up all the connections and have servers in the mines. It doesn't pay off. Okay, so really important to keep this in mind. I had another one in Czech Republic, where they wanted to count people in train stations. Okay, because the train stations send to the government information say, I served 100 passengers, so you need to pay me a certain amount of money. Okay, and they wanted basically a one-off count. They only wanted to do it once. So this is not an AVA project, right? It's get someone in there and count people for a day, right? The second one is, check up the available bandwidth. This is a serious issue. So for that 8,000 video cameras, monitoring cameras that I mentioned, I found it strange that in every single call they would ask, "What about bandwidth? What about bandwidth?" And I'm like, "But AVA, really cool technology," and they were like, "Bandwidth." So, just make sure that that's in place, and only send video up if you really need to. And the very last note regarding the quality of machine learning models, devices, and Steffi alluded to this. Devices like these consumer grade, or hobbyist grade devices, they may not be able to run fully featured neural networks. So you may have to do a process called quantization, where you lower the quality of the neural networks, but you make them faster, right? So you may have to judge what you do depending on what you can do on the device. Okay.
So on the device side, as we have already seen, so it's very important to find first the right hardware architecture, but then really also test the video stream that is coming in to compatibility. For example, what we haven't mentioned so far is that AVA only can record video that are MKV, right? Matroshka.
H.264. Yeah.
H.264. So you really have to pay attention to the hardware, but also to the video formats. Then, as we already saw, or I saw in the last two weeks, is really GPUs and drivers are complex. And also for the NVIDIA Jetson, but also for other devices, please test how many how many streams they can actually run in parallel. So, for example, the Jetson could run more than one video source in parallel. But it doesn't mean, depending on the model, depending on the hardware itself, that it's actually performant. So really the secret here is test, and really build a strategy beforehand, how you're actually going to deal with the hardware and the videos. And also, that's also my personal thing, I get contacted quite regularly by customers who are telling me, Iot Edge is not working anymore. And I'm like, did you test the disk space? Is it full? No, it can't be full. Check it. Oh, yeah, it's full. And that even more applies to live video analytics, because there are big, huge video files. And if you have a local file sync that you can also use, it really is pumping everything full in terms of disk space in no matter what. And for production, it's very important also in terms of, let's say, NVIDIA. For the consumer-grade devices, you always have to reflash them. So if there is some cool feature that you want to use, and you have thousands of Jetsons, for example, just as an assumption, in the field, you would need to have some strategy. NVIDIA, to be fair, offers an SDK manager where you can do all that stuff, but it only runs on Linux AMD 64 devices. So I couldn't use it on my Windows, and I couldn't use it as a VM because it needs a local wired connection to the Jetson. And I didn't have an AMD 64 Linux device at home, like for this demo, because it was too short noticed. But this is something that I also encountered. And also be really careful about the responsible use cases of AI. That's what Joao mentioning, that you only have use cases where you do no harm, and also have the ethics in place and everything. Be responsible also with AI.
And also GDPR.
GDPR, yeah,
it's also
good
a
one.
question.
GDPR.
So just to tell one last story. When I was in the UK before, we had a project for a supermarket chain, and they wanted to have video cameras and detect footfall. So, men spend more time in this section, or men usually go to supermarkets at 7:30 to get a quick dinner, for example, right? This was one of the insights that they had. But the issue is, formally, according to GDPR, even though they don't know who that person is, the person can go to that supermarket and say, delete all my videos. even though they don't know who the person is. So legally, we had to get their legal involved. So the project was canned. It could not be done if faces were being seen. Okay, so not only responsible users, but also privacy. Okay, and
that's all.
That's all.
Thank you for listening in.
So what do I press now?
Still.